What if I told you that the single most dangerous thing you did for your kidneys this week was eat a banana, not a cigarette, not a can of soda, a banana? Now, before you dismiss that, stay with me for just 60 seconds, because what I am about to show you is one of the most counterintuitive and frankly disturbing paradoxes. I have encountered this in over a decade of researching metabolic and renal physiology. It is a paradox that I believe is silently accelerating kidney damage in millions. Here is the thing that haunts me about kidney disease. It does not announce itself. There is no alarm, no pain, no warning light. Your kidneys can lose 50% capacity, and your standard blood work will still read as normal. The creatinine number your doctor glances at? That number does not even begin to rise until you have crossed into serious damage. So the question is not whether your kidneys are working. The question is, how much of them is left? I am a medical researcher specializing in metabolic aging. I have spent years studying the biochemical intersection of diet, inflammation, and kidney function. And today, I want to walk you through exactly what is happening inside your kidneys right now, and 4 specific fruits grounded in molecular science that can help protect what remains. This is not fear-mongering. This is biology. And the moment you understand the mechanism, everything changes. Let us get specific, because vague health advice has caused enough damage. Your kidneys are not simply filters. That analogy, while convenient, dramatically undersells what they do. Every 60 seconds, your entire blood supply, roughly 5 liters, passes through your kidneys. Inside each kidney sit approximately 1 million microscopic structures called nephrons. Each nephron is a coiled system of capillaries and tubules that performs a staggering array of functions simultaneously. It filters waste, regulates electrolyte balance, sodium, potassium, phosphorus, manages blood pressure through the renin-angiotensin system, activates vitamin D, and even signals the bone marrow to produce red blood cells via erythropoietin. When nephrons die, they do not regenerate. That is the brutal fact. And the insidious part is this: the surviving nephrons compensate. They work harder, filtering more blood per unit, a process called hyperfiltration. The body masks the loss brilliantly, for years, sometimes decades. Creatinine stays flat. GFR looks acceptable. The patient feels fine. But hyperfiltration itself accelerates damage. Those overworked nephrons are under mechanical and metabolic stress. The blood vessels within them are being pushed beyond their design tolerance. The scarring deepens, and eventually, often without warning, the compensatory mechanism collapses. That is the moment creatinine spikes. That is the moment the doctor says, "Your kidneys are not doing well." And by then, the damage already done cannot be undone. This is why I focus not on creatinine, but on the glomerular filtration rate, the GFR. GFR measures actual filtration volume per minute. It is the truest window into how much kidney function remains. And the 2 forces destroying that function most aggressively: uncontrolled hypertension and uncontrolled blood sugar. High blood pressure hammers the delicate capillaries of the nephron like a fire hose against a paper screen. High blood sugar coats and clogs those same filters in a process called glomerulosclerosis. Think of pouring slow syrup into a precision instrument, hour after hour, year after year. The inflammation and fibrosis that follow are the real disease. Now back to the banana. When your kidneys are functioning normally, potassium management is effortless. You eat the banana, potassium enters the bloodstream. Your kidneys detect the rise, activate the appropriate channels, and excrete the surplus into the urine. Balance restored within minutes. The system is elegant. But reduce that GFR, say to 50% of normal, and the elegance collapses. The kidneys no longer have the filtration capacity to clear the potassium load quickly enough. Blood potassium rises. This condition is called hyperkalemia, and hyperkalemia is not a minor inconvenience. Potassium governs the electrical polarity of every cell membrane in your body, including, critically, the cardiac muscle cells that make your heart beat. Elevated potassium disrupts that polarity. The result can be palpitations, muscle weakness, or in severe cases, fatal cardiac arrhythmia. The same paradox applies to phosphorus. Dairy, nuts, seeds, dark colas, all high in phosphorus. When the kidneys cannot excrete it, the body compensates by releasing parathyroid hormone to pull calcium from bone, trying to balance the phosphorus-calcium ratio. The result is renal osteodystrophy, progressive bone weakening. Worse, that liberated calcium and excess phosphorus deposit together in arterial walls, calcifying them. Flexible arteries become brittle pipes, blood pressure climbs, and that elevated blood pressure drives further kidney destruction, a downward spiral with no natural break. This is the brutal irony I keep returning to in my research. The foods we confidently call healthy can, for the wrong person at the wrong stage of kidney function, act as accelerants on a fire that is already burning. Which means strategy, not just nutrition, is what matters. And strategy means choosing foods that are low in these burdensome minerals, while simultaneously delivering active compounds that directly reduce inflammation and oxidative stress at the nephron level. 4 fruits do this exceptionally well. Let me walk you through each one with precision. The apple is chronically underestimated, and that frustrates me because molecularly it is one of the most sophisticated kidney protective foods available. First, the basic profile. A medium apple is low in potassium and very low in phosphorus. From a standpoint, it is almost ideal for a compromised kidney, but its therapeutic power lies in the skin. Apple skin is densely packed with pectin, a soluble fiber that does something remarkable in the gastrointestinal tract. Pectin acts as a biological binder. It forms a viscous gel in the intestine that physically traps phosphorus molecules and certain uremic waste compounds, carrying them out of the body before they ever enter the bloodstream. In effect, pectin is performing a secondary filtration pass in the gut, removing load before it even reaches the kidneys. Beyond that, pectin functions as a potent prebiotic. It selectively feeds beneficial bacteria, specifically strains like Bifidobacterium and Lactobacillus, that produce short-chain fatty acids, including butyrate. Butyrate is a primary fuel source for intestinal epithelial cells and a powerful suppressor of NF-κB, the master inflammatory signaling molecule. This is the gut-kidney axis in action. A healthy gut microbiome directly reduces the systemic inflammatory burden that the kidneys are tasked with managing, and the apple skin contains quercetin, a flavonoid that inhibits xanthine oxidase, one of the primary enzymatic sources of reactive oxygen species in kidney tissue. Studies published in journals including the Journal of Nutritional Biochemistry have demonstrated quercetin's direct cytoprotective effects on renal tubular cells under oxidative stress conditions. Finally, apples have a low glycemic index, meaning they produce a gradual, blunted insulin response, which is critical when blood sugar management is central to kidney preservation. Eat the skin, always. If I had to choose one food above all others for kidney protection at the molecular level, it would be the blueberry. The biochemical rationale is this. Blueberries are extraordinarily low in both potassium and phosphorus. Their safety profile for kidney patients is nearly unmatched among fruits, but their power is in their anthocyanins, the pigments responsible for that deep blue-purple color. Anthocyanins are among the most potent antioxidants found in any food. They neutralize reactive oxygen species through multiple pathways simultaneously. They activate NRF2, the master antioxidant transcription factor, which upregulates endogenous antioxidant enzymes, including superoxide dismutase and catalase. They suppress NF-κB signaling, directly cooling the inflammatory cascade at the genetic level. And critically, they protect the vascular endothelium, that single-cell thick lining of every blood vessel, including the glomerular capillaries that do the actual filtering work of the kidney. Research from the American Journal of Clinical Nutrition and other peer-reviewed sources has shown that regular anthocyanin intake is associated with improved insulin sensitivity, meaning the body requires less circulating insulin to clear blood glucose. Less insulin means lower glycemic stress on the glomeruli, less syrup in the filter. A practical note: freezing blueberries does not degrade anthocyanin content meaningfully. Frozen blueberries, which are typically harvested and frozen at peak ripeness, are a fully viable and often superior option to off-season fresh berries. Half a cup, several times per week, is sufficient to achieve measurable anti-inflammatory benefit. Red grapes are a case study in why color in food is not decorative. It is biochemical signaling. The skin of red and purple grapes is one of the highest natural sources of resveratrol, a polyphenol that has been studied extensively for its effects on cardiovascular aging. The kidney-heart connection here is direct and non-negotiable. Your kidneys are fundamentally a vascular organ. They are, at their core, an enormous bed of blood vessels performing continuous, high-volume filtration. Anything that damages your vasculature damages your kidneys. Resveratrol's primary mechanism is the activation of endothelial nitric oxide synthase, ENOS, the enzyme responsible for producing nitric oxide in blood vessel walls. Nitric oxide is a vasodilator. It signals smooth muscle cells in arterial walls to relax, widening the vessel and reducing resistance. The result is lower blood pressure. And lower blood pressure means less mechanical stress on those delicate glomerular capillaries. Resveratrol also activates the SIRT1 pathway, a sirtuin associated with longevity and metabolic regulation, and has demonstrated anti-fibrotic properties in renal tissue, meaning it may directly slow the scarring process that causes permanent nephron loss. The protocol here is precise: a small handful, 15 to 20 grapes, eaten with the skin intact. Not grape juice, which strips the fiber and concentrates the sugar. Not raisins, which are dramatically higher in potassium per gram. Whole red or purple grapes, eaten as a deliberate, strategic dose. Pineapple is the most misunderstood fruit on this list, and the most pharmacologically fascinating. Most tropical fruits are disqualified for kidney patients immediately because of high potassium content. Bananas, mangoes, papayas. Pineapple is the notable exception. It is low in potassium, making it one of the very few tropical fruits that does not impose a mineral burden. But its distinction is bromelain. Bromelain is a proteolytic enzyme, specifically a cysteine protease, found in the highest concentrations in the fibrous core of the pineapple fruit. In the body, bromelain exhibits powerful anti-inflammatory properties through a specific mechanism. It degrades fibrin, the protein scaffold that forms the structural basis of scar tissue. In the context of kidney disease, where fibrosis, the progressive scarring and stiffening of kidney tissue, is one of the primary mechanisms of irreversible damage, bromelain's anti-fibrotic action is clinically meaningful. Research published in the European Journal of Pharmacology and several immunology journals has documented bromelain's ability to modulate inflammatory cytokines, particularly TNF-A and IL-6, both of which are elevated in chronic kidney disease and directly contribute to progressive nephron loss. Bromelain also functions as a mild natriuretic. It promotes sodium excretion through the urine, which contributes to blood pressure regulation by reducing fluid retention and vascular volume load. One critical point: this applies exclusively to fresh pineapple. The high heat processing of canning completely denatures bromelain. Enzymatic proteins are structurally fragile. Canned pineapple retains the sugar and the potassium, but none of the therapeutic enzyme. Fresh only. And eat a portion of the tough central core, which is where bromelain is most concentrated. These 4 fruits, apple, blueberry, red grape, fresh pineapple, are not a cure. I want to be absolutely unambiguous about that. They are precision tools, and like any tool, their effectiveness depends entirely on how they are deployed within a larger strategy. In my research, I have observed that the primary obstacle to dietary consistency is not motivation, it is monotony. People do well for 2 weeks, then fatigue with repetition and revert. So I advocate a simple rotation framework. Early in the week, a whole apple with skin as a snack. Midweek, half a cup of blueberries with breakfast, fresh or frozen, it does not matter. Later in the week, a small counted handful of whole red grapes. On the weekend, a cup of fresh pineapple, including some of the core. This rotation serves 2 purposes. First, it ensures biological variety. Each fruit delivers different antioxidant and anti-inflammatory compounds working through distinct molecular pathways. Quercetin from the apple, Anthocyanins from the blueberry, Resveratrol from the grape, Bromelain from the pineapple. They are not redundant, they are complementary. Second, the rotation makes the habit sustainable across months and years, which is the only time frame that matters for chronic disease management. But these fruits cannot compensate for unmanaged blood pressure, uncontrolled blood sugar, excess sodium from processed foods, or inadequate hydration. The fruits reduce oxidative burden and inflammatory load. The lifestyle controls the primary drivers. Both are required, neither alone is sufficient. If you are managing kidney function, the conversation with your physician must include GFR tracking, not just creatinine, as well as a review of your current potassium and phosphorus intake in the context of your specific GFR level. Dietary restrictions appropriate for someone at GFR 45 are not the same as those for someone at GFR 70. Precision matters. I want to pause before I close because I think this matters. Most of the people watching this video are not in a hospital. They are at home doing their own research, trying to understand what is happening inside their bodies before it becomes a crisis. That is not fear, that is wisdom, and it is exactly why the Eternal Vigor Way exists. If this research-based approach to understanding your health, not just what to do, but why it works at the molecular level, is something you want more of, then I want to personally invite you to subscribe to this channel. Every week, I publish content built on the same foundation you just watched. Real mechanisms, real science, no shortcuts. Your health decisions deserve that level of depth. Subscribe and bring someone with you. Share this video with someone whose kidneys you care about. Your kidneys have filtered every meal you have ever eaten, every medication, every glass of water, every late night. They have been working without complaint, without a single symptom, for every year of your life. What the research tells me, and what I want to leave you with today, is this. The window to act is almost always earlier than you think. The kidneys are resilient. They respond to reduced burden. They benefit from targeted nutritional support. The fire can be slowed, sometimes significantly, when we understand exactly what is feeding it and what is cooling it. Apples for their pectin and quercetin. Blueberries for their anthocyanins and insulin sensitizing effects. Red grapes for their resveratrol and nitric oxide activation. Fresh pineapple for its bromelain and anti-fibrotic properties. These are not folk remedies. They are biochemically understood interventions, low in the minerals that burden failing kidneys and rich in the compounds that protect what remains. I am a researcher in metabolic aging and renal physiology. This has been the Eternal Vigor Way. Take this seriously, because your kidneys already are.